So now that we're about halfway through the course, you've all had a chance to experience the trials and tribulations that is programming. You've noticed that you write some code, you try it out, sometimes it works, sometimes it doesn't work, sometimes the problem is really easy to find and fix. Other times you spend hours pulling your hair out, maybe some tears and things like that, but eventually you do get to the end. You do get to the finish line. And man, does it ever feel good when you do. Man, does it feel good when you solve those really, really challenging problems. So today's lesson is going to focus on identifying the 3 types of errors that we find in programs and some tips and strategies on how to actually overcome them or solve them. This doesn't take into account which development environment you're using, whether you're using something like REPL or whether you're using Visual Studio or Eclipse or whatever tool that you're using at the time. It's really irrelevant. So this is all general case. So there are 3 main types of errors we see. The first one is something called a compiler error. We've already talked about these. So these are also known as syntax errors. So these are errors that happen before your code even gets running. So errors that prevent your program from running, they occur as a result of bad syntax. Basically, the program cannot compile your code into machine code because you wrote something wrong. So these are the most common types of errors, but usually the easiest to fix because in all the tools that we use that compile our programs, they give handy dandy little tips and instructions of where to find the problem and exactly what the problem is, usually anyway. And that might even include like an exact line number or something along those lines. So they're fairly easy to fix. Now, most compiler errors are caused by mistakes that we make when we're typing our code. So what do I mean by that? Most common one is, of course, forgetting those semicolons, right? Forgetting a bracket, having too many brackets, spelling a word incorrectly. So, for example, you might misspell a keyword. You might leave out some necessary punctuation, or try to use a variable before it's even defined. That happens all the time. So here's a quick little example. Imagine I'm trying to create this variable called test variable, and the data type I chose is bool. Obviously, that should be bool in Java. That would be boolean, right? So we need to make sure that we're specifying the correct type. So let's take a look. Let's see how well you learned your lesson. Pause the video for a second and see how many compiler errors you can find here. I'll give you a hint. There are 8. See if you can find them all. Okay, let's see if you got them. Now, the first 2 lines, they're good. There's no problem there. We have int phone number and int age 21. No errors on there at all. But as soon as the program gets going into the actual logic, we see a flood of them. The very first one we see is that we spelled phone number wrong. So that's going to give us an error saying it doesn't recognize the word phone number. The next one we see is this number. We're trying to put this number here. Obviously, that looks like a phone number to us, a Toronto phone number. And we're trying to insert it into an integer. We're trying to store it into an integer. But the problem is the maximum value for an integer is about 2 billion. Well, this number is over 4 billion. So you're actually going to get an error saying, nope, it doesn't fit. Next, we see this if statement, but we have the wrong I. If is spelled incorrectly. It needs to be little if, okay? The next thing we see is the comparison statement. Is age... Wait, that's not right. It's not equal to or greater than. It should be greater than or equal to. So we should flip those 2 signs around. Okay. What's next? We're missing our opening curly bracket for the if statement. All right. Right line is forgetting the console dot right line. The text we're trying to display is missing its quotation marks. And finally, that line is missing its semicolon. So in this tiny, tiny little program, there's literally 3 lines of code there, and there were 8 errors on 3 lines of code. So you can see how challenging it can be, or how much of a pain it can be if you're not precise when you write your code. You need to take your time and actually go through and make sure things are correct, make sure your decisions are correct, and why you're making those decisions. So anyways, so those are the compiler errors, easiest ones. Then we get into the runtime errors. Now, before I get into this, let's talk about one thing first. There are 2 stages of every program. There's what's called design time and runtime. Design time is basically all those things that happen before the program runs. You're designing the code, designing the logic, okay? So that's where the compiler errors kick in. Runtime is when the program is actually executing. So if there's a problem here, The runtime error will actually crash your program. The program will cease, and it'll give us some kind of error message saying, whoa, this is what just happened. Now, you've seen this in regular programs outside of your own before too, whether that's Windows getting the blue screen of death, or whether that's some program just crashing all of a sudden, you have no idea why, things like that. That's because they ran into what's called a runtime error. Errors that occur while your program runs. Usually when your program attempts some kind of impossible operation. For example, you want to convert boat to an integer. Well, you can't. As much as you'd like to, you can't. So these errors cause our programs to crash while running. Not a nice situation, not very elegant. It's very abrupt, and it just destroys the user experience. So here's some common examples of runtime errors that we see all the time. Dividing by 0. Now, you can't divide an int or a byte by 0. That will actually crash the program. However, you can divide a double by 0, and that will give you a result as infinity. Literally, if you display it on the screen using a console.write line, you are going to get the word infinity on the screen. Where else? Sorry, tried to convert incompatible data. So boat or 6.7 to an integer. Now, those are both strings. Now, if this were just quote 6, I could convert that to an integer using try parse or whatever I want. However, 6.7, not so much. That won't work. It's not compatible with an integer, so it will fail. Trying to access an index of a string that doesn't exist. So we know that we can access individual elements of a string using the square brackets. Well, let's assume that we have a variable called word, which is a string, and we gave it the value hello. If we try to do this, word square bracket 10, which means it's trying to access index 10, or the 11th letter of word, it's going to give you a runtime error because there is not 11 letters. In fact, there's only 5 letters. So the maximum index here is only 4. So we're 6 past the end of the string. So this gives us a runtime error. Usually we say this is an out of bounds exception. You went past the end. And then finally, Stack Overflow. You've seen the website before. This is where it gets its name. Stack Overflow error is basically when your program runs out of memory. It just has no more to work with. Now, we won't see this much in the grade 10 or the grade 11. You'll see it a lot in the grade 12, though, because the stuff that we do starts to stack on the memory pretty fast. So let's try your knowledge again. So here I have another program, and I want you to find the runtime errors. So pause the video and see if you can find them all. Okay? There's only a few in this one, not too many. Okay, let's see if you're back. All right, so the first thing we want to look at is this. So if we are trying to convert, total pay is an integer. So we're trying to convert whatever the user types in into that integer. But if the user types in 685.50, remember that's going to come in as a string 685.50. So when we try to convert that to an integer, it's going to fail. You cannot do that. We could convert 685.5, the number, to an integer because it would just do the banker's rule around it, but not the string 685.5. That will not work out. Okay, so that's our first error, our first runtime error due to the input. The next one is down the next line. You'll notice that we're dividing by hours, but hours, wow, we forgot to update the amount of hours in the program. So it is still set at 0. So when we go to do this division, and because we're dividing integers, we're actually going to end up with a divide by 0 error. So those are 2 quick runtime errors that we see fairly commonly. You're going to see a lot more. Finally, the big one. Now this is the big tamale here. Logic errors. So these ones are painful. These are the reasons that you pull your hair out and those tears come out and you complain, you curse Mr. Lane's name. And I get it. I understand. I've been there. I went through it. Unfortunately, they're usually a result of our own ineptitude, and we made mistakes and things like that. So what are logic errors? Errors that prevent your program from doing what you intend it to do, producing an unexpected result. So these errors will not break your program. They only give incorrect results. So think about this for a second. You don't actually have an error per se. You don't. What you have is bad results. So us, the programmer, made a mistake in the logic that we created. Something is wrong with our logic. Now, sometimes we don't even notice it. Sometimes the product will be shipped out to the consumers, the customers, and as programmers, we didn't even notice at all. Now, if you think about this, if let's say you build a piece of software and you test it for thousands of hours, you have 50 people testing it for a total of thousands of hours. That's great until it gets into the hands of the public, and the public might be millions of people. Well, if you got 50 people testing for thousands of hours, let's say 1,000 hours each, well, that's only 50,000 hours worth of testing. If you get 1 million people test for 5 minutes, you've already trumped all that testing. So that's the difference. So 1 million people are going to find way more problems than your 50 people can, very quickly. So, like I said, a lot of times these errors just go out the window, right out to the customer, and we don't even know that they're there. Somebody eventually tells us, and then we build a patch and we fix the program. Okay, so here's an example of a logic error. When you add length and width, when you're trying to find the area of a rectangle, well, that just means you made a mistake with the operator. That happens. It's going to happen to all of us. So because these errors do not break our program, they often go unnoticed, as I said. This also makes them the most challenging to find and fix, because you don't even know what is the cause of the problem. So when you see something incorrect in your results, let's say it's a value, whatever it is, you have to work your way backwards. You got to find the source of the problem. So let's go over some tips on how to, actually no, before we get that, let's do a quick little test to see if you can find some logic errors. So here's a very simple program, and there are 3 logic errors in this program. Pause the video and see if you can find them all. Okay, so here we go. The first one, where we're multiplying out here, radius still has a value of 0. We forgot to give it a value, so which means when we multiply, anything multiplied by 0 is 0, which means every single time our result is going to be 0. That's not good. Secondly, we're trying to calculate the area, but this is not the formula for area. This is the formula for circumference of a circle, 2 pi r. We should have been doing pi r squared. And then finally, let's see if you guys caught the last one. The last one is in the output line. We're trying to display the area, but we accidentally wrote the radius variable there to concatenate, which means we outputted the wrong value. So those are 3 very simple logic errors and not uncommon. Okay. So how do we actually approach all these problems? For compiler errors, they're always the easiest ones to fix. Always start with the top error. Chances are a whole bunch of errors that are below that don't actually exist. It's just the top error creating more errors because it didn't work out. So always start at the top. Fix one error at a time, then test it again before you go on to the next error, because as I said, it probably made a whole bunch of them disappear. When we get to runtime and logic errors, we basically approach these the same way, but let's break this down. With runtime errors, your program crashes on a very specific line, and typically whatever tool you're using, whether that's REPL or Visual Studio or Eclipse or whatever, they're always going to give you the error. They're always going to give you some form of indication of where that error occurred. Maybe it's a line number, or maybe it's an explanation of the code, that kind of thing. But you got to read and you got to track it down. If it's a logic error, well, you got to use process of elimination. You got to see what the problem is, and you got to work your way backwards to get to the line that actually has the problem on there. So once you know where the error is, you're going to handle both of these types of errors in the same way. First thing you're going to do is you're going to analyze the line with the error on it by looking at the method calls and the data given to those method calls. Okay, so what is actually in that line in terms of logic and information? So when you're looking at those variables and that data, check their type first, then check their values. Are they correct for what you're trying to do? Work your way backwards now to say, okay, well, this has this value. Well, how did it get that value? And then you work your way backwards to say where that value was calculated. And you keep going until you find the source of the issue. If you're still stuck, then it's time to do something called tracing your code. So this means you're going to step through your code logically, one line at a time. So you give it some data and you're literally going to step through manually looking through your program one line at a time, saying, okay, what's happening on this line? Okay, now what's happening on this line? What are my current values? Oops, sorry. What are the current values? And then finally, make use of temporary output statements to display those variable values. So You can run the code, output an output statement. So if you're in C#, that might be a console.writeLine. If you're in Java, that's system.out.println. But you're going to do it right there on the spot. Okay? You're not going to you're going to have a whole bunch of these. So you might say, well, I don't even know how far my program's getting before it causes the problem. So you might have ones that just output simple basic statements like A, B, C, D, E, and F. And if it gets to C, that means it didn't get to D. So you got to figure out, well, what happened in between C and D so you can track down the issue. Okay? If you're using other tools such as Eclipse or Visual Studio, you can actually use the debugger and step through the line of code as it's running, which is a much, much more powerful tool. REPL, unfortunately, doesn't offer that functionality at this point. So there you go. There's all the different types of errors that we've seen so far and how to approach them. Now going forward, hopefully you'll be able to do this. Your homework tonight is going to be to fix a very, very broken program. Good luck with that.